Hello everybody, welcome to the unit 3.1 of the lead MOOC. In this video, we'll see the basics on freight modeling. First, we'll start with an introduction to what is a model and why is this relevant for developing a digital twin. Then, we will proceed to give an overview of the urban freight system that we will be modeling and tuning in our digital twin. So, we will be describing and showing which are the main agents and assets in the urban freight transport system. Then we will go briefly from all the models that are included in the digital twin platform and which is their role. Finally, we will summarize what we have learned today. First of all, what is a model? A model is a simplification of reality. That is, we take whatever element we think is relevant for our model and we simplify it in order to have better understanding of what's going on. Models consist of a set of assumptions that are made in order to reduce the complexity of the system. That is, in real life, whatever we want to understand or to model, it's very complex, has a lot of details, but not all of them are relevant to what we want to use. So modelers tend to have different sets of assumptions in order to reduce this complexity and have a manageable size of a model. The assumptions relate to which aspect of the system do you want to model and which objectives do you want to have. And for example, if you have a demand model, you might want to have an assumption that is that the population has certain homogeneous properties, so they behave similarly. This is, of course, not necessarily true, but it helps a lot to simplify the element to understand and to have some results from it. Why is this important for a digital twin? Well, we said in the other units that a digital twin is a representation of a physical environment. So if we want to take all the complexities of the physical object into a digital representation, we will have to make some simplifications and we will have to have some assumptions that will be key to what is the scope of the model. So in an urban logistic digital twin, what do we want to model? We want to model the urban freight system. The urban freight system is a complex set of agents that interact between them and have different types of objective itself. So, for example, one of the main agents are the shippers. The shippers are the ones that have the product, that own the produce and want to send it and deliver it to their customers. They interact, for example, with the transport service providers that are the ones that actually do the delivering, that carry the parcel in their vans and do the routing. This can, of course, be the shipper itself, but in this case, they have a different role. Then you have the shops as an intermediate point of selling. You have the customers, the final customers that are the ones that will drive the demand. And you also have the public authority that has the role of keeping the whole urban system running. What the urban freight system also works on the assets of the different agents that are involved. For example, warehouses that are in the city, the network, so how is the delivery network configured by the transport service providers, for example, and also the environment. Because the urban freight system, as we know, has a lot of externalities towards the environment, so it's a relevant element to model as well. As we mentioned before, there are different types of models, and these models can have different, can be characterized between the different types of scope that they have. For example, we can organize them through the time scale. For example, strategic models that deal with long-term movement of agents. Tactical that relates to medium-term logistics decisions, and operational that tend to look to very short-term decision making. For example, a strategic decision in urban freight system is to where to locate a depot, for example, a warehouse. A tactical decision is to how are you fulfilling, how is your parcels, for example, which composition or which sequence of warehouses and delivery depots will you use. And an operational level would be, for example, which route would your vehicle take. Also, we can characterize our models by the level of aggregations. For example, we can have zonal level models, that is model that take or divide the city in different zones that have certain characteristic that makes them homogeneous towards inside and heterogeneous towards the outside. So you separate different parts of the city. Or you can also have the models that take the parcel of the shipment level. So they are very disaggregate, and you can model how is the behavior of each parcel or shipment. So what type of models does our digital twin include, that the lead platform includes in its digital twin? Well, first of all, optimization models. Optimization models are models that have an objective function that they want to minimize in case of a cost or maximize in the case of profit. As a result, we will have, for example, routing that minimizes the cost of delivering a parcel. We can also have network models. What do network models do? Well, network models take shipments or routes, and they plot them or they take them down to the network. In this way, we can translate a shipment or that certain, for example, logistics service provider has into an effect, into a vehicle in the city, so we can measure the impact. Also, talking about measuring the impact, we have impact assessment models. So we summarize and we measure which KPIs are important in order to understand what is the overall effect of certain delivery policy. We also have agent-based models. Agent-based models model the behavior of each individual agent that we mentioned before, and how do they interact between them. These have the advantages of having very detailed relationship and quite behaviorally appropriate of each individual agent. Finally, we have demand models. Demand models are models that want to replicate or to understand how do consumers make choices and demand, for example, either parcels, so we will have a parcel demand, or how do they make choices between different logistics service providers. For example, they want to buy from carrier A or from carrier B. So, what have we learned today? We first highlighted the importance of models in digital twin. So why do we want to represent and to make simplifications of the real urban freight system and to be able to twin it and to include it in a representation of reality? Then we also talked about what is the system that we want to model, this urban freight system, which agent does it have, and all the multiplicity of assets that they have to deal with. Finally, we give a very brief introduction to which model types are included. In the following videos, we will go more into detail of what does each model type do and what is their limitations and what are their roles in the digital twin. So, hope that you join us for the next session. Thank you.